for G period and if you guys need it. So Quinn, can you hit that closest light to me at least? You can hit another light if you want, but at least that one. So we are adding on to our identity sheet. We're getting into chapter or part 5.3, and I want to do the first 3 questions, but in order to do them, we need to add identities. And I'm going to teach you one so then we can use it and you understand what we're doing, and then we'll learn the other 2. We're going to call these sum/difference identities. Essentially what happens is that we're going to find the sine, cosine, and tangent of an angle that can be made from using 2 other angles that we're going to know from the unit circle. So I'm going to start with sine of A plus B. I don't know what A and B are. It could be 45 and 30. It could be 180 and 45. It could be like any of those we're going to kind of try and break down and use. That's going to be equal to sine of A times cosine of B.
By the sine A.
Yep, I will zoom out in 1 second. Plus or minus sine of B cosine of A. So sine of A plus or minus B is equal to sine of A times cosine of B plus or minus sine of B times cosine of A. The reason I have a plus or minus is that if I'm adding the 2 angles together, then I'm going to add in my formula. If I'm minusing the 2 angles together to get the angle that was given to me, we're going to have a minus in the equation. So next to that, I'm going to write sines match. And I want to use this so that we can kind of see why we're doing this, and then I'll teach you the ones for cosine and tangent. So I'm going to write sines match. So if I had a plus before, I'm going to have a plus after. All right, let me get my actual notes out now.
That's the one we're adding?
For right now, we're going to add a cosine and tangent one, but I want to do this one just now so we know what we're doing with it. Because you probably look at this and you're like, I mean, it seems fine, but I don't know what the point is. So the first example in 3.5, it says find the exact value of sine 15. 15 is not on your unit circle, though. Can you use 2 angles on your unit circle to get to 15? What could I use? 45 and 30. There's a couple different options, but we'll do those. So I'm going to say sine of, it'll be 45 minus 30. 45 minus 30 is what gets me 15. Now I have a sine of a difference. So I'm doing A minus B. And I'm going to break that apart and I'll do, okay, sine of 45 times cosine of 30. I have to have my signs match, so it's going to be minus sine of 30 times cosine of 45. So let's break it apart. We'll say sine of 45 times cosine of 30 minus, and I'll zoom back out a second, sine of 30 times cosine of 45. So 45 minus 30 gives us 15. So we break that apart to be sine of 45 times cosine of 30 minus sine of 30 times cosine of 45. Now we actually know those numbers, right? What is sine of 45? Root 2 over 2? What about cosine of 30? That's a harder one. And then it's the other one, root 3 over 2. Minus, and then sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Again, I'll zoom out so you can see. I'm just trying to write semi-nice today. Okay, now I multiply those together. Root 2 times root 3 becomes root 6. 2 times 2 becomes 4. Minus 1 times root 2 becomes root 2, and 2 times 2 becomes 4. This is perfect. I've got my little denominators ready to go. I'm going to combine these to just be 1 fraction root 6 minus root 2 all over 4. All right, so do you kind of see why we're doing that now? A little bit? Okay, I'm going to teach you the cosine and the tangent one, and then we'll go try and do those last 2 problems. So cosine is very similar. I'm gonna write cosine of A plus or minus B. But this time, instead of it going cosine or sine, cosine, sine, cosine, I want both my cosines together and then both my sines together. So it'll go cosine of A times cosine of B, and then sine of A and sine of B. And again, I'll zoom back out in a second if you need it. Cosine of A times cosine of B, and then sine of A, sine B. The only thing is the thing in between them is not a plus or minus, it's a minus plus. Great question. The difference is that if I have a plus between A and B in the original part, then I'm going to minus, I'm going to do the opposite sign when I get into my equation. Similarly, if I start with, it's not the same sign. I'm going to write next to it, instead of signs match, I'm going to say signs opposite. And when you have a minus, I got to change that to a plus. I got 5 minutes. I know, I'm sorry. I mean, you can always learn this on the video, but I'd rather be here to teach this to you. And then we'll learn tan really quick, and then we'll plug in for the last two, if I can squeeze that in. Tangent looks just a little bit different. Tan is going to be a fraction, so I'm going to write tan of A plus B, plus or minus B, excuse me. And when I make that into a fraction, it's going to go tan of A plus or minus tan of B. And then in the denominator, it's going to be 1 minus plus tan A times tan B. In this case, the top matches, the signs match, and the bottom goes opposite.
Is that a 1?
1, that's the one at the very beginning. 1 minus plus tan A times tan B. I lost my N there. All right, once you have those two down, flip back over to your note sheet. Let's see if we can actually do cosine of, what is it? It asks us cosine of 165 and then tan of 195. Okay, cosine of 165, I'm going to ask what two things could add or subtract to be 165. How about 30 and 30 plus what gives me 165? 135. And that's on our unit circle, right? So we're going to break that apart to be cosine of 30 times cosine of 135. Remember that in the cosine, it goes a minus plus. So if I had a plus here, I need to do opposite signs, which means I'm going to have a minus there. And we'll do sine of 30 times sine of 135. All right, anyone remember what cosine of 30 is? Root 3 over 2. What about cosine of 135? Awesome, negative root 2 over 2. What's sine of 30? 1/2. And then sine of 135? Root 2 over 2. Multiply those together, I get root 6 over 4 minus root 2 over 4. That root 6 has a negative. I don't think I said that, so make sure you carry that through. And then we can combine that to one big fraction. You're going to see a lot of these same numbers, root 6s, root 2s, 4s. If I go look at the tangent one, tangent of 195, how can I break that apart? $150 and 45. Let's at least set it up and then we can finish it. Tan of 150, we have to match on top, so it's going to be plus tan of 45. And then I do 1 minus, we have to have opposite signs, tan of 150 times tan of 45. Okay. G period, I'm going to pause and finish you in a second. Okay, G period, I'm just finishing this problem really quick for you. I hope this transfers on the YouTube right. We have tan of 150 and tan of 45. We should all know that tan of 45 is 1. I think we've done that one enough. But tan of 150, you might not know. That ordered pair on your unit circle is negative root 3 over 2 comma 1/2. And so we have to remember that tangent goes y over x. And so we're going to solve that out. Some of you might remember because we've done this enough times that you probably have an idea of what's happening. But we're going to get negative 1 over root 3, which rationalizes to negative root 3 over 3. Again, this was an old skill, so you should know this, or you should at least be able to go back and look at something else to practice. But I'm going to take these two numbers and plug them in to tan of 45 and tan of 150. So we just said tan of 150 was negative root 3 over 3. Tan of 45 is 1. On the bottom, I get 1 minus negative root 3 over 3 times 1. And I just want you to clean that up a little bit by multiplying that denominator. I can make that negative root 3 over 3 plus 1 all over 1 plus root 3 over 3. You can simplify that farther, but I'm not going to ask you to do that as of right now. So I'll zoom it out for a second if you need to look at that. Again, we have to know what tan of 45 is and 150, and then we just plug and chug, and then that's it. So these are your notes for today after your quiz. If you need anything, I have office hours on Monday. See me then.